Precipitation means formation of insoluble solid, which separates when you're adding two water soluble substances together. And if I'm going to go to next slide, if I were to write the chemical equation for this reaction, so can I say we are starting with lead 2 nitrate, and this is the formula of lead 2 nitrate. Lead 2 nitrate, as you see here, it's a water soluble solution. How do I show that lead nitrate is water soluble here? Aqueous means you have a water soluble solution. And we are adding sodium iodide. This is water soluble. So I am going to show that this is aqueous as well. Meaning of aqueous solution, clear solution, the substance is water soluble. And that's the meaning of aqueous. Now, these two are reacting together. Do you see there is experimentally we see formation of solid? And I give you a table which will tell you whether lead iodide is water soluble or not. So by looking at that, you know the solid part is not sodium nitrate, but it's really lead iodide. So what about sodium nitrate? Sodium nitrate is water soluble. How do you know that the sodium nitrate is water soluble? I give you a solubility table. Solubility table, and you get this on exam. You can easily look at the solubility table and see what compounds are water soluble. Any ionic compound which is water soluble, it simply means in water it breaks down to counter ions. For example, if lead nitrate is water soluble, can I say that it really means that lead nitrate breaks down in water to its counter ion, which is Pb plus 2, positive charge, and NO3, negative charge. So I could say the same thing about sodium iodide, because based on the solubility table, I can tell that it's water soluble. That means in water it breaks down to positive ion and negative ion. And PbI2, the fact that PbI2 is not water soluble, it's a precipitate. That means it doesn't break down in water, it stays as PbI2. And then sodium nitrate water soluble, that means in water, the solution, it really is found in the form of negative charge and positive charge. So what you see now, I have converted what was called a formula unit equation into ionic equation. Now, guys, do you see this is an equation which has got two identical terms on opposite side, just like algebraic equation where you can cancel identical terms from both sides of an equation. Is it fair to say that I can cancel an A plus and NO3 minus together? So now let's see what is left in our simplified equation. And we call, by the way, this equation is called ionic equation. Why? Because we're dealing with ions. Can I now cancel NO3 and NO3 cancel each other? An A plus, 2Na plus with 2Na plus are going to cancel each other. So what is left in this ionic equation? On the left-hand side, I have Pb plus 2 and I minus, and Pb plus 2. That's all I have left on the left-hand side. And on the right-hand side, I have PbI2, which is in solid form. Everything else is gone. So this is what we call net ionic equation. A net ionic equation shows the real players in a chemical reaction. Do you see Pb is in the ionic form? Now It's bonded to I2, so it has changed. So it's iodide. I minus, it's in ionic form, and now it is bonded to Pb. So we call this reaction as net ionic equation. It is showing the ions which reacted and produced a new product. Now, as you see, Na plus did not change before and after. NO3 minus did not change before and after. So they are not really doing any changes. They are not doing anything. They are simply sitting and watching the reaction between Pb plus 2 and I minus. So I'm going to call this spectator ions. Spectator ions are ions which do not change, do not get involved in the chemical reaction. So this is the method that you can write net ionic equation for a precipitation reaction. I hope this makes sense. If it doesn't, please make sure to come and see me and let me explain this to you. The next slide. This is what makes your life very easy. I'm not going to expect you to memorize all these solubility rules. I just give you a table. All you have to do to decide whether something is water soluble or not. Let's say you want to see a Pb and I water soluble. You choose the column of Pb, you choose the column of I, you are writing here. If it is a solid black, solid gray, it means it's not soluble. This means not soluble. Or if you want to see if copper iodide is copper 2 iodide, this is I, and that's copper. Is CuI2 water soluble or not? Do you see? It's a white cell. White square means yes, water soluble. So this is water soluble. This is CuI2. It's water soluble. This is not soluble. So PbI2 is a solid in water. That's how you use this table. It's an exam table on Canvas. Make sure to use this table so you're familiar with it during the exam. This is another solubility rule. It's there for your reference. I'm not going to ask you to memorize this. Just use the solubility table I showed you before. By repetition, eventually you learn these rules. Okay. So let's summarize how you write a net ionic equation for a precipitation reaction. Step number 1, write a balanced formula unit. What's formula unit? If I say, what is the formula unit of NaCl? That's formula unit of NaCl. And if I write this is the ionic structure of NaCl. So write the formula unit. That means show the component of the compound together. And next, write the ionic equation showing dissociation of strong electrolyte. What is the ionic equation for NaCl dissociating in water? That's what it is. And these are both water soluble, so I write aqueous here. Next step, determine precipitation from solubility table. I showed you how to use solubility table. Use the table to decide what is water soluble and what is not. If it is water soluble, you write aqueous. If it is not, if a compound is not water soluble, you simply write S for solid. And next, cancel spectator ions. That means cancel ions which are the same on both sides of the equation. This is just like algebra. It simply means consider chemical equations like algebraic equation and cancel identical terms from opposite side of an equation. Next, let's take a look at this reaction. Let's take a look at this problem. Can you write the net ionic equation for reaction of silver nitrate? That's silver nitrate with sodium chloride. Sodium chloride. But before writing the net ionic equation, I have to write the chemical equation. These are two binary compounds. Do you see this has got positive charge, negative charge, positive charge, and negative charge. And remember we said metathesis reaction, or when two binary compounds react together, you can predict the product by double replacement reaction. That means Na is replacing Ag, so you're going to have Na, NO2B as one of the products. And it also means Ag is replacing Na, so Ag now is partnered with Cl. The next part is, what is solubility of these substances? What should I write in this parenthesis? What should I write here? And here as well. And here as well. So use that table I gave you. Silver nitrate, if you use that solubility table, it's water soluble. Table salt, of course, we know that is water soluble, aqueous. Sodium nitrate is water soluble according to the table of solubility, and AgCl is actually not soluble. You write S. All right. So now we have a chemical equation. This is using formula unit. That means I haven't broken apart the ions. So because this is water soluble, I can write it as Ag plus and NO3 minus. And because NaCl is water soluble, it means in water it breaks down to its corresponding ions. Because NaNO3 is water soluble, it breaks down to its corresponding counter ions, AgCl, which is solid. It means it doesn't break down to ions. So now, what's the next step? Can I cancel Na plus and Na plus? What else can I cancel? Can I cancel NO3 and NO3? So what is left is going to be the net ionic equation. On the left-hand side, I have got Ag plus, which is, of course, soluble in water, and NO3, which is aqueous. And on the right-hand side, all I have is AgCl solid. So this is the net ionic equation for this problem. Let me clean up my whiteboard and show this again to make sure you got it. And if you have any question, please don't hesitate to come and see me during my Zoom hours, and I can answer your question. So stepwise. Number one step, write the formula unit reaction. Write the equation using formula units. You decide solubility by using solubility rule. Next step, break down all the water-soluble ionic compounds into their corresponding ions. Next step, cancel identical ions from both sides. We call them spectator ions, Na plus and Na plus. They are spectator because they did not change. They didn't take part in the chemical reaction. And then write down what is left over. That's net ionic equation.